All right, so this lesson is for Pre-Calc 11, chapter 5, section 3, A, radical equations. It says here, when we think of the square root of 9, there's actually two solutions that may come to mind. Well, when you take the square root of 9, what you're asking for is what numbers can you think of that square itself will equal 9? Well, the first answer is, of course, 3. 3 times 3 would give you 9. But as it turns out, -3 times -3 also gives you positive 9, right? When we square them. All right, so it says here, however, when a radical is given, an expression or equation, only consider the positive response. So solve x squared is equal to 25. Well, x squared is equal to 25 when you take the square root of it. Again, you have to think of all possible answers. Well, the first answer, of course, that works is positive 5. But -5 also works because if you were to square that, that would also equal positive 25. Now, when it's asking for simplify square root of 25, well, this, of course, is then, positive 5 or -5. Okay, it says here in this section the radical is given in the equation, so only consider the positive solution. So we're only interested in this one. All right, now it says here steps to solving the radical equations. Well, first of all, we need to find the restrictions on the variable in the radicand if the index is even. Remember that the radicand must be set greater than or equal to 0 and then solved. If you multiply or divide by a negative number, you flip both sides. You flip the inequality, okay? So the direction of the inequality. Get the radical all by itself on one side. If the index is 2, you square both sides. If the index is 3, cube both sides, etc. And then solve for the variable. Check if the solution is affected by the restriction. And number 5, check the answer using the original equation to see if the solutions are valid or extraneous. So let's do this very first example. 2 square root of 6x minus 1 is equal to 11. So what we want to do is we want to isolate the square root. So we're going to add a 1, add a 1. 2 square root 6x is equal to 12. The next thing we do is we want to divide by 2. Divide by 2, we get rid of the coefficient. And then we have the square root of 6x is equal to 6. Now, how do we get rid of something with an index of 2? Oh, you square it. So whatever you do to one side, you do to the other. And now we're back to 6x is equal to 36. And we divide both sides now by 6. X is equal to 6. You always want to verify this is true. So is this true? 2 square root of 6 times 6 minus 1. Does that equal to 11? Well, because we have an index of 2, that's a pair. We can cancel that out, pull it out. 2 times 6 is 12. Minus 1 is equal to 11. 11 does equal to 11. So that works out okay. Example B. Same idea. We want to isolate the square root. So we have a -8, so we're going to add 8, add 8. And now we have what looks like 3y over 5 inside the square root is equal to 10. Because our index is 2, we are going to square it. And whatever we do to one side, we do to the other. And now we have 3y is equal to 3y over 5 is equal to 10 times 10, that's 100. We're going to multiply both sides by whatever's in the denominator to get rid of the fraction. So it's 5. 5. And on the left-hand side of my equal sign, I have what looks like a 3y is equal to 500. Y is now equal to 500 over 3. And of course, we would verify this. So I'm going to verify this. Negative 8 plus square root of 3 times 500 over 3, all divided by 5. Does that equal to 2? Well, 3 and the 3 cancel out. Negative 8 plus what looks like 500 over 5. Does that equal 2? Well, 500 over 5, that's really 100. Let me take the square root of that. Oh, that's a plus. Negative 8 plus 10. Does that equal 2? Absolutely. Okay. So, the next example. 4 plus the square root of 2x minus 3 is equal to 1. So here's the original question. Well, we subtract 4, right? Because the idea is to isolate the square root. And then we have the square root of 2x minus 3 is equal to negative 3. Well, my index is, of course, a 2, so I'm going to square this side and square this side. What am I left with? I'm left with a 2x minus 3 is equal to 9. I'm going to add 3, and 2x is equal to 12, and now x is equal to 6. Of course, like before, we're going to verify. Is this true? 4 plus 2 times 6 minus 3. Does that equal to 1? I don't know. 4 plus 2 times 6 is 12, minus 3 is 9. 4 square root of 9. Sorry, 4 plus the square root of 9. Is that true? Well, it's not true. This is actually wrong. Therefore, x equals 6 is extraneous. Okay, so algebraically it works, but when you plug it in, it doesn't work. Here we go again. We have m minus the square root of 2m plus 3 is equal to 6. We always want to isolate the square root. So what I can do is I can go m minus the square root of 2m plus 3 is equal to 6. I can subtract m from both sides, so I got negative 2m plus 3 is equal to 6 minus m. Now, I'm going to multiply everybody by negative. So I'm going to negative everybody, and that becomes, this becomes positive. 2m plus 3 is equal to, well, that becomes a negative 6, and that becomes a positive m. So here's my positive m, here's my negative 6. Okay, right? 6 is positive here, now it becomes negative. And here's my negative m, and it becomes positive. All right, so we know my index is 2, so I can square this. And what are we left with? We're left with what looks like a 2m plus 3 is equal to m minus 6 times m minus 6. Well, that's just distribution. So 2m plus 3, and I'm going to draw the arrows to describe what's happening. So m times m is equal to m squared. M times negative 6 is negative 6m. Negative 6 times m is negative 6m, and then a positive 36. I don't know why there's a bracket there, so let me just get rid of that. I'm going to set everything equal to 0, and the 2m plus 3 on the left-hand side. I'm going to move it over to the right-hand side, and I'm going to collect all the like terms. So m squared minus, here's negative 12m, and then if I move the 2m to the other side, that becomes negative as well, so it's negative 14m. I have a positive 3. If I move it over to the other side, it becomes negative 3, so it becomes positive 33. Well, here is a polynomial, and we talked about factoring. I draw my little x, and I ask myself, what two numbers add to negative 14 and multiply to positive 33? Well, hopefully you would agree that negative 11 and negative 3 work. So 0, so m, negative 11, m negative 3. So what are my roots? What are my zeros? My possible answers are m equals 11 and m equals 3. Now let me shrink this down, because now we're going to verify. So let me draw this in half. I'm going to verify. And the original question was m minus 2m plus 3 is equal to 6. So I'm going to check m equals 11. Is this true? 11, subtract. 2 times 11, that's 22, plus 3. Does that equal 6? Well, 11 minus 22 plus 3, that's 25. We take the square root of that. Yep, that works. Now I'm going to test the other value. 3 minus 2 times 3 plus 3, that's 6, 9. Does that equal 6? Well, 3 minus the square root of 9, well, that's just 3. It doesn't equal 6. So we only really have one solution. M equals 11. M equals 3 is extraneous. And we will continue on the rest of the examples in the next video.